Hello, this is the Math 1113 Zoom meeting for Tuesday, February 16th. And we are covering sections 5.5 and 5.6 this week. The end of chapter 5, so there's no quiz this week. We will have test 2 covering 5, 1, 2, 3, 4, 5, and 6 on Friday. It will be proctored. Section 5.5, practice problems, page 479, problems 3 through 27. Section 5.6, practice problems, page 486, 3 through 9, 11 through 31 odd. Web assigned problems on your personal study plan, practice quiz, section 5.5, problems 1, 2, and 3. Section 5.6, 1, 2, 3, and 4. 7 total problems. Just email me the percent of these problems that you get correct. There are 2 laws in trigonometry, due to sines and cosines. And so 5.5 is something called the law of sines. It's a little simpler. 2.5.6, the law of cosines. They're intertwined. They allow you to find angles and sides of non-right triangles. You to find unknown angles and sides of non-right triangles. I think I should use the word general triangles. Okay. 5.5, we'll abbreviate this LOS, and we'll abbreviate law of cosines LOC. It works off the area of a triangle. You may be familiar with calling this the base, this is the height. If you had a rectangle, squared it off, so to speak, or whatever, made a full rectangle, your area would just be base times height. But when you cut it corner to corner, you have the area. So a triangle, your area is a half times base times height. The dirty little secret is they did not tell you, dirty secret, there has to be or B and H have to be perpendicular to each other. Have to have a right, which is 90-degree angle between them, which they would on a rectangle or triangle like this. Triangle formed from a rectangle. So more generally, rotate the H toward B. And we should point out that you really could write this 1/2 base height sine of 90 degrees. If you rotate the H towards B, they usually call this an angle alpha. So here's your base, here's your height. Your alpha is not 90 degrees, and your angle becomes 1/2 times base times height, and it turns out sine alpha. And the alpha is angle between B, and H. They show you this in the book. I didn't cover it back then. It's in section 5.3, another formula. They have a triangle with sides. They use an A and B for side length, included angle. That's called the included angle. Make the theta there 90 degrees, and you have your standard 1/2 base times height. Okay, so what's the big deal? The big deal is, I'll use their conventions, trying to keep the confusion out, because I'll probably use the same conventions on weather sign. Diagram 475. This corner A, B, C. They use capital letters. You could call them corners, vertices. So, corners. And small letters on their opposite sides. A little a here, a little b here, and a little c. The c's I got to be careful about. They tend to look identical. So if I get sloppy with the size of them, you can get them confused. So this is angle A, this is angle B, and this is angle big C. And then the side lengths are small letters opposite the matching corner letters. So you can write the area 3 different ways. And just to show you where I'm getting that, again, it's figure 2 here. So I'm working off this diagram. All right, using what I just gave you about area, you can write the area 1/2, pick any two sides. Let's pick A and C, and angle B is between them. Sine of big B. This is between A and C. All right, but that's the same thing as if I picked B and C, and then A is between them. Sine of big A. Well, that's the same thing as if I picked 1/2 A and B and did the sine of big C between them. All of them will give you exactly the same area. Now, you're not really used to working with 3 different things in equations, so I can pick them any 2 at once and do it, but I'll just do all three at once. You can multiply through by 2. Killing the halves. AC sine big B has to be equal to BC sine big A has to be equal to AB sine big C. Now I can divide by anything I want. I can divide by 10 million if I wanted. That's legal. It doesn't help you any, but it's legal. Divide by ABC, the product of all 3 side lengths. And 2 letters in each one will cancel. So the A, C, C, and you wind up with a sine of big angle B over little b. Its opposite side is equal to, here the B and C cancel, sine of the big angle A over its opposite side is equal to, A and B cancel here, sine of big C over little c. This is law of sines, but you use it 2 at a time. can also use it upside down. Little b over sine big B, little a over sine big A, little c over sine big C. Okay, in plain English, in plain English, for any triangle, any triangle, the sine of any angle over opposite side is equal to the sine of any other angle over its opposite side. And so this is used to solve these types of problems. Angle, side, angle, side, side, angle. Come to side, no. Side, side angle. Okay. What is this gibberish? This is called angle, side, angle, or side, side, angle. Where am I getting this gibberish? So basically, you're given an side between two angles. You're given a side between two angles. Here you're given two sides and the angle is around the corner. Two sides given together, angle around the corner. Okay. LOS solves these problems. 3 and 4, side, angle, side, 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 angle, side, 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 side. LOC, law of cosine, solves these problems. LOS fails. I'll explain that when we hit 5.5, maybe in 10, 15 minutes. I think I'll get into it now. I think I'll just use examples of law of sines now. And then it's pretty straightforward why your law of sines fails. LOS fails on these kinds of problems. It's pretty straightforward why. But let's do some examples of law of sines and then we'll explain. And that's why they came up with the law of cosines. Okay, Examples 5.4. I guess we'll just charge into the first one, 3. X, this is 24.6 degrees. This is 98.4 degrees. And you got 376 over here. They're labeling this B, this C, and this A. Okay, and one other thing, they usually report answers the precision of data in the problem. All right, so this is whole number precision. This is whole precision on the sides. So I'll report the answer here to whole number precision. I'll report to whole number precision. It's just a little quirk in the things. I don't make a big deal about, how many places you report your answers. And I won't do a true or false based on if I said 2 and you reported 3 or something like that. I won't do it that anally or ticky. Okay. There can be multiple ways to do these kind of problems. You want to set up LOS. It's a proportion. You can set it up any way you want. I start with my unknown. So I start with X. And I would need it over the sine of angle C. It's opposite the sine of the angle on its opposite side. Okay. Then I would need, I got no way to get this side, so I can't use the 24.6. It's not a Pythagorean theorem. That only works on right triangles. So I've got to use, you got to line it up. I got to use 376 over the sine of 98.4 degrees. All right, well, how do I find angle C? Well, I hope you remember from basic geometry, for any triangle, all angles add 280 degrees. So C, angle C, plus 98.4 degrees plus 24.6 degrees has to add to 180 degrees. It's proved it in high school geometry. Hope you remember it. You got any triangle, all the angles always add to 180 degrees. So angle C is pretty easy to find. I'm just going to go 180, subtract 24.6 degrees, subtract 98.4 degrees. $57 degrees. Interesting thing about the calculator, by the way, notice I used the degree symbol. Do you have to be in degree mode or radian mode to do this? People always get tripped up about that. Was I in what? Check. I was in, notice I was in radian mode, but I still got this. Let's do it in degree mode. 180 minus 98.4. Amazing, it's still 57. I got the same answer in radian mode and degree mode. How can this be? Because this is just arithmetic. you're combining numbers themselves, the calculator doesn't care if they're in radians or degrees. It's only when you do a sine of something in degrees, you got to be in degree mode, or a cosine or a tangent. If you're computing a function, you got to pay attention to the mode. So this says x over sine 57 degrees. I'm going to plug c in there, is equal to 376 over sine 4 degrees. Now, you could cross multiply. But that leads to two steps. Leads to two steps. Sine x times sine of it equals 3 sine of this. And yeah, then you got to divide by it. And that's, you know, it works. If you like to cross multiply, help yourself. But all I really can do, all I really need is to multiply both sides. I need to multiply both sides. Sine 57 degrees. Sine, get one more step in on this page. X over sine 57 degrees is equal to sine of 57 degrees times 376 over sine 98 degrees. You see, this cancels. And you can get it down to one step if you'll start your proportion with the unknown. All right, and then I kind of punch it all at once. I'm going to write the 376 first, then sine of 57 degrees, and you're going to divide it by sine of 98 degrees. Equals, okay. Make sure now you're in degree mode. Now, make sure you are in degree mode. Here, calculator mode doesn't matter. Doesn't matter. If you're just combining numbers and not taking a function of them, it doesn't matter. But it matters here. Am I in degree mode? I am now. 376. Sine 57 divided by sine, I think I lost the decimal. 98 point, it was 98.4, my fault. 98.4. 98.4. 318.7596. Okay, if you left that as an answer, I wouldn't mark it wrong. The book, I'm pretty sure, will probably have x equals 319 because they seem to be reporting the sides in integer precision. We'll double check. 3 uses 5.5, number 3. Oh, I'm wrong. 318.8. They reported it to one place because the angles were in one place. The book actually had 318.8. They reported it to one place because the angles were given to one place. Were given to one place. Okay, if you'd reported at 319, I wouldn't have marked that wrong. I'm not that picky about the rounding, and I'm not going to do a true or false based on tricky rounding like that. Just to show you that the degrees do make a difference, let's put it in radian mode. .376 sine 57. See, that's 57 radians, and you're dividing by sine 98.4. And yeah, you get a completely different. See, in radian mode, you get an X of negative 193. I'll call it 0.6. Completely nonsensical. Okay, because it took 57 radians over 98.4 radian, completely different. So that's when you got to watch the mode. It's really a shame to do everything completely right, but have your calculator in the wrong mode. Okay, what would be a different one? Let's see, 3 to 27 odd here. Okay. Why don't we try number 9? Page 479, 5.5. .65, 46 degrees, 20 degrees. They call this A, this B, this C. You can use any letters you want. You just got to pay attention to the convention of using angles over opposite sides and like. Now, solve the triangle. Solve triangle means finding all missing sides and angles. So I'm going to come across there and call that little a. This is little c, because it's opposite big C, and this is little b, because it's opposite big B. We have integer precision here. So answers will be in integer precision. Okay, we can get angles. If I'm missing an angle, I got 2 other angles, I always go for the missing angle first, because that's the easiest. In other words, we want to find angle C, little a, and little b. Well, angle C is pretty easy to find. You're taking 180 degrees, subtract 20 degrees, subtract 46 degrees. Remember, calculator mode doesn't matter. You're just doing numbers, and whether this in degrees or radians, you'll get the same answer out of this subtraction than you will do in degree mode or radian mode. Minus 46 minus 20. Or punch in the order I wrote it on paper, and 114 degrees. I do try to, keep the confusion down, make sure that I do write the degree symbol if we're in degrees, as they did up here. Leave it off, it's not technically correct. It's sloppy, you're calling it 114 radians. All right, the rest of this, it doesn't matter, the order you go for these things. I guess I'll go for A first. So step 1 there. All right, so to A over sine of the 46 degrees would equal, I'll have to go, see, I can't use B over there because I have 2 unknowns. So I'll use 65 over the sine of the 114 degrees, angle C. And you see all I got to do is multiply by sine of 46 to clear the fraction here. And I'll have A by itself equals 65 sine divided by sine 114 degrees. Don't really need any parentheses or anything. And now you got to be degree mode. Okay. Yeah, I'm gonna make sure. Nope, I'm in radian mode. Degree mode. So yeah, I did this calculation in radians and it doesn't matter. Okay. All right, so I have 65, keep them both on the screen here, 65 sine 46 divided by sine 114. 51.18. If you left it 51.18, I wouldn't mark it wrong. And the book will probably call that 51. Integer precision. Okay. Third one, define B. And you can do it, any way you want. You need B over the sine of 20 degrees. Keep the picture up. So B over the sine of its opposite angle. I've got the choice now now that I know A over sine 46. So some people will tell you, stick to stuff that's given in the problem. You'll get more accurate answers. You can do that, or you can use, the answer you got. If you just use the 51 over, your answers might be off somebody who's using the 51.18. You can do it any way you want. I'll go with 65 over the sine of the 114. And you get used to solving these things really quick. Pretty easy solve. You just multiply both sides by sine of 20. 65 sine 20 degrees divided by sine 15 degrees. Make sure you're in degree mode. I still am. Sine 20 divided by sine 114. 24.335. Book, we call that 24. Okay. Integer precision, pretty straightforward. Let's try one they don't give you a picture. Page 480. 13. No picture. I'll tell you angle A, 50 degrees. Angle B, 68 degrees. And little c is 230. All right, you got to be careful with triangle. If you want to really be sure, use diagram. Page 475, where they're putting big A there, big C there, big B there, little a, little b, little c. You just can't set these things up willy-nilly if you want to get the answers in the back or you want your WebAssign answers to match. You really got to be careful to line things up opposite what they tell you they are. So they're telling me this is 50 degrees, that's angle A, and they're telling me this is 68 degrees, and they're telling me the little c down here is 230. So you see you have a classic side, angle side angle problem. This is an angle side angle problem, which was one of the ones Law Science is intended to solve. Okay. Again, you can go at this any way you want. I'll start with angle C. Find C. We're solving this triangle. And it would be 180 minus 50 minus 68. You repeat a lot of the same steps in a lot of these triangles. Notice I never check the mode doing something like this, 62 degrees. I should call that big C, the C's get a little, if you get sloppy with the size of them, get a little confusing. Okay. I guess I'll find A. A over sine 50 degrees must equal, I can't use B because I have two unknowns. I have to use the 230 over sine 62 degrees. Multiply both sides by sine 50. Sine 50 degrees, so A equals 230 sine divided by sine 62 degrees. Now I check the mode. Yep. To sine 50, sine 62, 199.54. Everything seems to be integer precision. I guess we'll call that 200. Again, if you left it 199.4, I'm not going to have, this and then this and make, true or false. They're both correct. Hey, yeah, I'm about finished with Zoom. And then find B. B over sine 68 degrees is equal to, I'll stick to the 230 over sine 62 degrees. Again, multiply both sides by sine 68. Write it out. Sine 68 degrees divided by sine 62 degrees. $241.52. They usually call that 242. Sure, yes, I was in degree mode. 241.52, 242. Okay, let's go on to LOC 5.5. Law cosines. And to understand this, you just have to understand they're out. They'll come back. LOS fails for side angle side and problems. Side, 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 easiest to see. Let's make 10, 12, 14. And you want to find an angle. Angle A, angle B, angle C. Well, if I go sine big A over its opposite side of 12, it equals sine big B over its opposite side equals sine big C over its opposite side. So you don't, no matter how you set this up, always have two unknowns. All right. Side angle side, that would be like going, so you're 10 and 14, and you've got 51 degrees between them. Angle A, angle B, angle C, this little a. Okay, so if you wind up with say A over sine 51 degrees, then you got to have 10 over sine big B And that would equal 14 over sine big C. So no matter which way you go, you always have the first two unknowns, last two unknowns, first 1 and 3, yeah, two, and always have two unknowns. Okay, so I'm not going to derive the law of cosines. The derivation, LOC, on page 482. It would take another 20 minutes. I'm not sure it would illuminate anything. They give you 3 different versions of it. But that's the exact same triangle as the last section, so I'm going to start with that. And I'm just going to write down one version of it. Big A, big B, big C, little a, little c, little b. You can pick a side. Say A. And it's the square of the other two sides, like it's a Pythagorean theorem. But there's a correction factor. Twice the same two sides product cosine of big A, and the trick is opposite that side. This angle opposite this side. That's the scheme. Okay, again, there's 2 other versions. If you start with any of the other 2 sides, the derivation is there. It would take another 20 minutes, and we're already almost 45 minutes in. So it's pretty straightforward to use. Page 486, number 3, say. Big A, big B, big C, X, 21, 39 degrees. All right, and they want you to find X. Notice it's a classic side angle side problem. You can spot this when you need to use law of cosines. You're given side, angles between the sides. That's a classic situation. LOC would say you take x squared and the other 2 sides squared minus twice those same 2 sides cosine 39 degrees. And it's really nothing but a gigantic arithmetic problem in degree mode. Because you're eventually going to punch this. Think of it as this is a correction factor. On the Pythagorean theorem. Notice it looks like a Pythagorean theorem. One side squares, the other 2 sides squared. A Pythagorean theorem. E-O-R-E-M. It's a non-right triangle. For being a non-right triangle, they figured out you've got to correct it because it's a non-right triangle. All right, so degree mode, yep. And this is pretty easy punch, it's a little long, but 21 squared, add squared, subtract 21 times 42 cosine, that's why they call it law of cosines, 39. 834.1145. 4, and x would then be the square root of that. You can do square root of the answer, 28.88. Seems to be integer precision, so we'll call it 29. Now, they call this version 1, find a side. We'll call this version find a side. Let's do version 2, find an angle. Let's see, how about number 7? Number 7. Using 68.01, 42.15. Call this angle, my version of this angle. We put B up there, put A there, put C here. And we call this 37.83 opposite that angle. Okay, so mine's a little fatter than theirs, but I've got everything in the right position. Number 7. Okay, I set this up the same way. If I want to know this unknown angle, I start with the opposite side to it. The other two sides don't matter what order they go in. Minus twice, same two sides. Cosine theta. We're going to have room on the same line. Cosine theta. And notice I have just one unknown. All right, so if you're really good with your algebra, you can solve the, or you can take 5 steps, moving every little piece over if you want. But if you're really good with your algebra, you can see all you got to do is take this, subtract this, and then all of this is nothing but a coefficient. You wind up dividing by it. So I go 37.83 squared, subtract the 42.15 squared, subtract the 68.01 squared. All right, that is moved. All that stuff over. If I then divide by the negative 2 times 42.15 times 68.01, I wind up with cosine theta by itself. And yeah, it's a kind of a long, nasty punch, but it really isn't hard. This is 2 hundredths place precision. We'll call it hundreds place precision. 37.83 squared. Subtract 42.15 squared. Subtract 68.01 squared. You can do this however you want. You should have put it in parentheses if you're going to punch the whole thing, but I'll just hit enter. You can divide by each of these pieces individually. Divide by the negative 2. Divide by the, by the way, this answer can come out positive or negative. If it's a negative, that means you're in the second and third quadrants. So negative answers are perfectly legal. All right, that divided by the negative 2. Now we'll divide by the 42.15. And now we'll divide by the 68.01. And I wind up with 0.8670 or so as cosine theta. All right, well, we did this a little bit in the earlier chapter to find theta. Take inverse. So I'll switch it up and show cosine theta is 0.8670. Notice it's less than 1 as it should be. Remember, sine theta or cosine theta always less than or equal to 1. Theta then would be the inverse cosine, 0.8670. Cosine. You can do second answer if you want. Answer 29.885 degrees. Y'all remember what this means? Is it just random gibberish? It means that at almost 30 degrees, 29.885 degrees, you have an x coordinate 0.8670. Now, this was hundredths place precision, so I guess the book would call it 29.89 degrees. To two places. I'll get the whole problem on, but I'll just double check this one. 5.6. I mislabeled this section, my fault. I just now noticed that. 5.6 is law of cosines. My fault. All right, so 5.6, number 7. $29.89 degrees, yeah. Read that. All right. Hopefully that's enough to get you going on 5.5 and 5.6. And we'll have another Zoom meeting end of the week. If you've got any questions, look forward to seeing you then.